We, with Caterpillar, have retrofitted self-driving haul trucks. Mining was an early adopter of this technology. It's amazing. You go on these mine sites, and there are these trucks where this entire room could fit in the back of the truck. And truck after truck is going back and forth, no one in it. And this isn't R&D, this is production. These are being used day in and day out. We also see about a 20% increase in productivity through this automation technology, which is a major benefit on top of the fatalities and injuries. We move to the defense side, where there's numerous applications. Today our warfighters will carry about 80, 100 pounds of gear on their back. That's a lot of weight. And imagine being on your feet 6, 8, 10, 12 hours a day. You can become exhausted. So why not take that gear, put it in a self-driving vehicle that's a mule, if you will, that you can hit a little button on a console, your mule will come up and you can swap out batteries or water or something like that. We also talk a little bit about IEDs. And for a while, the mindset was we take these mine-clearing vehicles and we put a driver on the inside. And then we lower these flaps down and they scan the ground for bombs and bad things in the ground. But you'll notice the tires are ahead of the scanners. And kind of the sequence here is, well, we'll add some more armor. Well, the bad guys make bigger bombs, so we add more armor, so they make bigger bombs. And before long, there's so much weight on these vehicles that the vehicles aren't very mobile. So why not get rid of the armor, like we've done with this partner, remove the driver from being inside the vehicle and make it autonomous, such that in the event that this does encounter an IED or a bomb, you're losing a vehicle, not a person or a human life. So here's where we are today with our self-driving technology. Over 10 years of driving innovation, we took our latest and greatest and went to the streets of Las Vegas the beginning of the year with CES. And we started giving rides to the public. And we'll talk a little bit about some of the challenging issues that we're facing and the self-driving car industry is facing at the same time. One instance here is not everyone follows crosswalks. We also have people who jump out between two cars, and I'm sure you all have never done that on campus. We also have cyclists that we have to worry about. You'll notice that our vehicle gets very conservative when we're around cyclists and pedestrians. We also have issues with adverse weather conditions. You saw some flooding ahead of time and some raining. Our vehicle has to adapt to these different types of technologies. And some of the questions that I think were sent beforehand were about LiDAR. And we've taken a multimodal approach where we use LiDAR, we use radar, and we also use vision. Because in some situations, one modality may work really well, but in another situation it may not. And by having that robustness, we can operate in a variety of different environments. Earlier last year, we did a cross-country trip. We autonomously drove from Washington, D.C. to Seattle and back. And it's very interesting. We encounter all these different types of terrain, but we also encounter different driving styles. If you go to Charlottesville and you compare that to L.A., you compare that to Boston or D.C. versus a small town that I grew up, we all drive a little bit differently. And there's also some gestures, there are gestures that take place between drivers, I guess, but I was thinking more of head nods and waving with all fingers. But different areas have a different driving code, if you will, and it's not really written down. It's just known by the locals, if you will. So here are some of the crazy things that we encountered at CES. So we're driving autonomously, we're going to perform a U-turn here, we're detecting the traffic light and everything else. Hey, everything's going great, no problem, and all of a sudden this truck is coming the wrong way down a one-way street. What's the safest thing to do in this situation? Some would argue, flash your lights, honk your horn, wave one finger, but what we find is this SUV that was driven by a human driver basically acted exactly like we acted. And one of the challenges that we run into is if I were to give you all a scenario and have you all break out into groups and say, what's the best thing to do in this scenario, or the safest thing to do in this scenario, there probably wouldn't be consensus in this room. But you know what's interesting is, you know, we look at machines and then we look at the human driver. And I may fly somewhere and get in a taxi, and the taxi driver, and this happens all the time, you know, is swerving, talking on the phone, accelerating, you know, abruptly, braking abruptly, and I accept it. And oftentimes it's because I can empathize with the person. Because I think, oh, well, this driver probably has a family, is probably working a double shift, and I give them the benefit of the doubt. But how well do we empathize with machines? And one of the challenges that we face, if I were to break you all into different groups, and Group A said vehicles should do this in this situation, Group B would say something else, and we deploy a self-driving vehicle to just do one of the different things that you all think it should do, how does society embrace that when we struggle to empathize with machines? I don't have the answer to it, but it's one of the big challenges that we face. Let's see. I can figure this PowerPoint out. I run a technology company. Here we go. So there's some other situations here. We're driving along. In this situation, we're at night. This guy really wants to move out. And these cars let him. We activate, we call it courtesy mode. And so we let this car pull in front of us. Now, there's some challenges with courtesy mode. Sometimes you show a little bit too much courtesy, and vehicle after vehicle starts cutting in front of you, and you really don't get to your destination in a timely fashion. So we sort of have, if you think about it, efficiency at one end and safety at the other. And sometimes when we drive and we don't have to be at a destination in a timely fashion, we may drive in a little bit more casual, courteous fashion. But if we need to get there, we may be like that white car, cutting in front of other cars. So another situation, and this was not an abrupt cutoff, but I thought it was interesting because we had a Kia that cut us off, and it went back into the center lane. And you're going to notice that they start rolling down their window. So the driver goes, "Hey man, is that thing autonomous?" Safety driver says, "Yes, it is." He goes, "Well, I intentionally cut you off because I wanted to see what a self-driving car would do." Which it's kind of interesting because he's making a great case for this self-driving technology, but he's also demonstrating one of the greatest barriers of this self-driving technology, which how do we perform the safest maneuver when some of these reckless and bad drivers, those that 93% of traffic accidents are, and it's not just a one-on-one, but you get clusters of these folks. So one of the things that we do within like our cross-country trip is not everyone obeys the speed limit. I mean, how many here obey the speed limit? Right? How many people go, show of hands, only 10 miles over the speed limit? Okay, how many go 15 over? Oh, yeah. I love honesty. Thank you. Because usually when this happens, you kind of see someone kind of looking around going like, yeah, I know I do it, but I'm going to raise my hand if they tell. So one of the things that we do is if the speed limit's 65, we may limit our speed limit to 75 miles an hour. And we let the passengers dictate that. And as we see the traffic around us sort of speed up to, let's say, I think I said 55 to 65. If we see the traffic go from 55 to 60 to 63, we'll keep up with that pace because we don't want to be a bottleneck. But at the same time, you could find yourself in a cluster of folks going 90 miles an hour. And that may not be a safe thing to do. So oftentimes, us as engineers will say, well, we just need to go and follow the rules of the road. But the rules of the road are really not well defined, and there's a lot of ambiguity, and most people don't follow them. And the rules of the road aren't necessarily the safest thing to do. So we have, pedestrians here. This is a little bit of a simpler situation, but we get kind of conservative. A lot of folks would just sort of, take a right here. You kind of have to predict what people are going to do, and as you get clusters of pedestrians, Usually pedestrians cluster together, but that's not always the situation, and they don't always follow the crosswalks. And in fact, when we had flooding, we had some pedestrians who would run to jump over the puddle so they didn't get their shoes wet. And then how do you go about predicting that? I remember we were at CES and I was getting ready to present, and the first day of CES, all this flooding that took place. And I was up on stage and I was talking about some of the challenges. And one of the challenges that we ran into was while we were testing, and it never floods in Las Vegas. So it was like 150 days of no rain, and it was the top, 6 rainfalls in Las Vegas history on the first day that we were giving public demonstrations in Las Vegas. So we were driving autonomously down the street, hit a puddle, splashed a bunch of pedestrians. I know it's awful, isn't it? But when you're developing this, that may not have been the first thing that you think about. When we were driving in the snow, I talked about this earlier, we were driving, and there was about 6 inches of snow, so you couldn't really see the lanes. Driving center of the lane, center of the lane, center of the lane. But you know what we weren't doing? Is we weren't following the car tracks of the vehicle that went in that lane before us. Because usually how you and I drive, we follow the tracks. So, these are some subtle things that start coming out from real-world testing. And we believe in simulation, and we can come up with a lot of great ideas, but there's nothing better than real-world scenarios here. And then, cyclists as well. And it can get kind of challenging when cyclists will go from the road to the sidewalk, back to the road to the sidewalk, which is one of the reasons we start to get very conservative around cyclists. And we also have instances where we're driving and traffic's on this side and motorcycles just come up in that middle lane, and it's really tough to see.